So let's pretend that this here is the ground and that this is a ramp at an 18-degree incline. This is a little box, and the box is being tugged at in this direction with a 60-pound force and with this angle of elevation. Now, the goal is to find, as you can see here, the goal is to find, it says, the magnitude of the effective force. You see, here is what I want to do. From this tip, I want to go down like this. It's perpendicular. Now, this here in orange, from here to here, that's the goal. I'm going to call that X. That's my goal. Because the box is being tugged at in this direction, but it's not going to move directly like that. The box is going to move like this here in that direction. And so, which is why this part here is the goal. This is your effective force. Let's solve for X. How can I find the length here? I can focus on this right triangle. That's really all I need. This right triangle where this is 60, this is 25, this is the goal. So I think that if we play with cosine of theta, right, cosine is adjacent over hypotenuse. This gives us the cosine of 25 equals the adjacent is X, the hypotenuse is 60. And if you multiply both sides by 60, this is gone. And so X would equal 60 cosine 25, which on a calculator is about 54.37. And that's actually the answer. We know this is the final answer, but we did this problem, without having to use like vectors or projections. And the conversation we had about this blue angle where you go like 18 plus 25 to get 43 degrees. We could have that conversation, but that would pertain to something else. We could do 43, like when they say, they call this vector u, and how u is, what was it, like a 60 cosine 43, and then 60 sine 43. You can do that there to find the components of this vector, to find the components. But we didn't want that. We only wanted the effective force of the box being pulled up the ramp, which was represented by X. So we did basic SOHCAHTOA to get the 54.37 pounds. But again, this here, that's something else, which we didn't need. We really only needed SOHCAHTOA for this problem.